Friday's Mobility Forum, Professor Daniel Freund will present the supply of autonomous vehicles in open platforms. Despite the recent challenges facing many AV companies, autonomous vehicle will come at some point. And when they come at a scale, they will fundamentally change the transportation landscape. Regardless of when and where, due to the high cost of AV hardware, one likely pathway for the widespread use of AV is via a fleet-based open platform, so that can sustain a high utilization and to outsource the high capital growth. And secondly, the human driver and the autonomous vehicle will coexist for a long time. So Dan today will describe a supply chain game between a platform, outside AV supplier, and human driving vehicles, and present a potential significant risk of the supply chain inefficiency and profit loss, and a few potential solutions to overcome this inefficiency. So before I formally introduce Professor Dan Freund, I do want to do one warm exercise. I would like everybody to type in the chat your organization, your city, and local time, just to give Professor Freund some context of who the audience is. So I would say MIT, Cambridge, 12 Great, thanks. That hopefully this is useful for you to understand the context here. And the second one, I will mention one expectation of this mobility forum, which is every participant, particularly the audience, to contribute one idea, either in the form of question or comment. Please also just type into the chat along the way, and we'll summarize it and pass it to the speaker as well. Dan Freund is the class of 1947 career development professor and an assistant professor of operation management at the MIT Sloan School of Management. His research focused on the complex decision-making problems in the sharing economy. During his PhD, he developed the analytical method used by bike-sharing systems like a City Bike, Boston Blue Bike, Ford Go Bike to inform their rebalancing, thus enable thousands of incremental bike rides every day. Prior to joining MIT, Dan spent a year as a research fellow at Lyft Marketplace Labs, where he developed new algorithms and market mechanism for ride-sharing industry. He received the 2021 APS Best Publication Award, the 2018 George Danzig Dissertation Award, and the 2018 Dan Wagner Prize for Excellence in Operational Research, and the Best Paper Award at the 2018 ACM SIGCAS Conference. Without further ado, I pass the forum to Professor Dan Freund. Dan, please.
Thank you for the kind introduction. Let me turn on the screen share. And as Junior just said, I'll be talking about the supply of autonomous vehicles in open platforms. By open platforms, I really am referring to companies like Lyft, companies like Uber, that are at least stating that the way they will operate is in an open manner in which companies can put autonomous vehicles on the platform, but also human drivers, independent contractors can continue to drive on the platform. So I'm going to talk about some issues that might arise in the way that supply would actually appear on these platforms or be deployed on these platforms. Now, this is joint work with my PhD student, Kamesi Zhao, who's on the talk and who's done most of the work, and with Ilan Lobel, who's a co-author from NYU. Now, for those of you that don't know me, probably most of you, let me introduce myself really quickly by talking a bit about my background. A lot of my work has been in bike sharing and ride hailing, but most of it has been very algorithmic, driven either by theoretical problems or very data-driven problems in those two contexts. Now, I've done some stylized modeling, actually some that I talked about 2 years ago in the Mobility Forum related to the introduction of Lift, Wait, and Save. But what I'll be talking about today was really a new sort of problem space for me, in that it's about a problem that doesn't exist today. So all of the other projects you see on here were about problems in bike sharing or in ride-hailing that were of relevance at the time. And of course, if we're thinking about widespread deployment of autonomous vehicles on Uber and Lyft, that is not a today problem. That is a future problem, maybe 2 years, maybe 5 years, maybe 7 years. And people on this call have a much better sense of what the right number of years would be. But in either way, it is not a problem that we're really concerned about today, but it is a problem that we believe, and I hope to convince you, will be an issue in the years to come. Now, I'm going to give you a tiny bit of background, and I won't give you much background on autonomous vehicles because people on this call, as I just said, have a much better sense of these than I do. But what I really want to sort of motivate with is this idea of underutilization, which will be the idea that autonomous vehicles potentially on these open platforms won't get as much use as one might expect, in particular, as the suppliers of autonomous vehicles might expect, and that this can cause problems. And what I hope to get to then is this idea that the problems that are caused, which I'm referring to here as SC, supply chain misalignment, can be overcome using contracting solutions. We'll explain all this in more detail down the line. Let me start with the very simple motivation that we already see autonomous vehicles being deployed in pilots on platforms like Uber and Lyft. There's actually a former master's student of mine on this call, Gus Castillo, who works for Motional. Motional at this point has partnered with Lyft and Uber in various cities to launch either robotaxis or delivery vehicles in various places. For example, on the left, you see self-driving Motional car that's piloted in Las Vegas. So the problem that we observe arising in this context, or that we believe will arise in this context, is that of underutilization. Let me try to explain what I mean by that. And I see there's one thing in the chat, so let me also try to make sure I can see the chat.
It's not important. Don't worry, Daniel.
Okay. So the way we will think about the autonomous vehicle supply chain in this talk is as one in which companies like Waymo, Motional, and many others will produce autonomous vehicles, but they won't sell them predominantly to the public, and they won't operate them in their own ride-hailing service, and instead they will deploy them to a company like Lyft or Uber, which Lyft has at least expressed as their explicit vision for an autonomous future. So Lyft has made very clear that they view themselves in the future as a hybrid network with both autonomous and human driver vehicles. Sorry. There. So we view the future as one in which we have autonomous vehicles that are being supplied by a company that produces them to the open platform. Now, the autonomous vehicles will be expensive, but once you have an autonomous vehicle, the marginal cost of operating it is very small because you don't need a driver in the seat. That's the very point of it. So we have, on the one hand, AVs that are being supplied to the platform at a high capital expenditure, but a low marginal cost. And on the other hand, you have contractors, human drivers, we will abbreviate them as IC, that are cheap in terms of capital expenditure to actually drive, in the sense of predominantly they may already have a car, and we do not expect them to actually require like a high fixed cost, but they have a high marginal cost, meaning for a contractor to spend the next 2 hours on the road, that is 2 hours of their time. So the marginal cost of operating is high for a contractor, it's low for the supplier, but at the same time, the contractor already has a car, the AV supplier needs to build a car, manufacture a car, and it needs to be an autonomous one. So the capital expenditure for the AV supplier is expected to be higher. Now, both of these will be on the open platform, and the open platform will need to decide how much demand to serve through each type of supply. And that decision will then end up deciding how rides are being served and how much money everybody's taking home. So let me talk a bit more about what this might look like. In operations management, in particular in supply chain management, there's a standard concept called dual sourcing. Now, the way we think about dual sourcing is that we may have low demand and we may, or like a base level of demand, and we may have scenarios in which demand is higher. And what we try to do is we try to serve our low demand through the type of supply that has low marginal cost, and our high demand through the type of supply that is flexible. So if you think about it, once you produce an AV, you've put in the capital expenditure and it's just there. So in that regard, it's not flexible because it's just always there. At the same time, if you look at the contractor might be willing to work just 10 hours a week or 5 hours a week. Whereas the AV, you've paid for it, it's there. The capital expenditure is gonna amortize over time, no matter what. So in that regard, what we would want is really the picture on the left, which is AVs will always serve our base demand. And if we are in the sort of setting where demand is high, then the remaining demand we will serve through contractors. Now, consider the example on the right. So suppose we have 20 autonomous vehicles, and those are already paid for. They're on our platform. And as a platform, we need to pay our supplier just $1 per unit of demand that they serve. Whereas when we serve demand through contractors, we need to pay them $15. At the same time, the contractors earn $15, want to earn $15 in order to actually show up. And now our demand will be either 20 or 30 with probability 1/2. And our contractors decide to join before the 20 or 30 realizes. In that case, when demand is low, how would you serve the demand? Would you serve it through autonomous vehicles that only cost $1? Or would you serve it through contractors as well that are much more expensive? And maybe a few people can just throw their answer in the chat as you're thinking about it. Serve it all through autonomous vehicles or use both autonomous vehicles and contractors? So we get a few answers. And one answer says, use AVs first to serve as much demand as possible, and then whatever demand is left, serve through contractors. That makes perfect sense. That is what we think of in supply chain management as dual sourcing. The base demand you serve through the cheaper marginal cost. The problem is in this setting that our contractors won't show up. So if we tried to only serve the low demand through autonomous vehicles, then our contractors are going to earn only $7.50 in expectation or on average. And they won't join because they want to make $15 in order to show up. So in order to meet the demand, the platform actually would have to dispatch half of the demand, even when demand is just 20, to the contractors. Now, what does it mean? It means that the autonomous vehicles end up being idle some of the time, despite their marginal cost being much lower. Now, one thing you might ask is, well, can't the platform just pay the contractors more? It could, but it actually wouldn't be the profit maximizing solution for the platform. So the profit maximizing thing for the platform to do in this case. I haven't given you a full example. I haven't told you what the per unit revenue for demand is. But the high level idea here is that in order to maintain contractors on the platform, it may be in the platform's interest to have autonomous vehicles be idle while contractors are being used, despite the fact that the marginal cost of the autonomous vehicles is smaller, potentially much smaller than the marginal cost of the contractors. Now, maybe this is just a cute mathematical observation, but let's take this a few steps further and see if potentially this could actually create problems in the incentives between the platform and the AV supplier. So let me go beyond this cute example and try to give you a model that won't capture everything, but it's going to try to capture certain aspects that we believe will actually be the case in an autonomous future. So the first sort of key driver of our results is that we assume that ICs have high variable cost, but no fixed cost, whereas autonomous vehicles have a fixed cost, but a much lower, or like at least a lower variable cost. Intuitively, this seems to be the only setting in which a hybrid platform, the way Lyft and Uber are talking about their future strategy, the only setting in which a hybrid platform would make sense. Now, beyond that, a few additional parts that go into our model. One, the autonomous vehicles are owned by the outside supplier. If we're thinking about Motional today, Motional still owns the autonomous vehicles that are deployed to Uber and Lyft's networks. The supply decisions of the AV supplier are made long in advance. So the supplier cannot say in our model, on a weekly basis, I'm going to just add or remove vehicles based on their usage. Those are big capital expenditures that are made years in advance with long-term planning and that can't really be adjusted at a reasonable cost in over a short time horizon. And then another assumption that we're making is that the platform, in the way that I just showed it sort of in the stylized example, can arbitrarily decide how to fulfill its demand through either the AVs or through the contractors, and there are no limitations on how it does that. Now, this is not the only set of assumptions that would make sense. For example, one could also imagine that AVs just can't serve all demands, which at least in an immediate future seems to be quite likely. But for today's talk, I will only focus on this sort of mental model for how things will be operating. Now, the three questions that we want to ask are first, can this type of underutilization that I described cause a misalignment where the supplier does not, for example, supply as many autonomous vehicles as would be socially optimal? The second follow-up question to that would be, if that's the case, how bad can the misalignment be? And finally, we want to know if there's something that can be done to address this issue. And the answers will be yes, bad, and yes. So we will find that there can be a misalignment. And this misalignment, at least in theory, could be really, really bad. In practice, based on ballpark guess numbers, it wouldn't be really, really bad. It would be somewhat bad. But we will see that there are solutions from the contracting world that can actually help us. And I realize I haven't told you yet what I mean by a contracting world. I will go into details, but for now, just think about the supplier and the platform agreeing to terms that will be beneficial for both and that go beyond just a pricing aspect, that go beyond just the platform saying the supplier will be paid some amount per usage. Now, our model has two features, or two interesting features. One, there are two types of decisions long-term planning decisions and short-term planning decisions, and it has two levels of stochasticity. So it's going to look like this. Initially, the platform agrees to how much the supplier will be served per demand served. Think of this as the platform saying long time in advance to the company, on a $10 ride, we're going to pay you $6. It's going to be like, we're going to take a 40% commission. So it fixes the amount that the supplier actually will receive per unit of revenue that arises from demand. In response to that, the supplier will decide how many vehicles to supply, how large its fleet size should be. This happens long in advance. And then on a much shorter time scale, the platform decides on how to serve its demand. Think of this as the platform tuning its dispatch algorithm. And the contractors then join the platform based on the dispatch prioritization that they experience on a daily basis. And then the second level of stochasticity is demand realizing. So the short-term planning is after a first level of stochasticity realizes. So think of the first level as being, are we in a pandemic? Yes or no? Are we in a good economic climate in which people spend a lot of money on ride hailing? Or are we in a bad economic climate? That's the first type of stochasticity. And the second level stochasticity, think of it as being on a given day, is somebody requesting yes or no? So it's much more short term. Think of this as being really the real-time randomness. Now, formally speaking, we can view this through a sequential game in which first the platform sets CP, which denotes the previously mentioned, the pay per demand served. Then the supplier sets the platform size. And then what we call a scenario realizes, the scenario being the first level of randomness. Then the platform tunes its dispatch algorithm, and based on that, contractors decide to join. Think of this as being like a week-by-week decision, and then demand realizes in real time. Now, there are some things taken from the literature in here, in particular, Hall et al. Studies on the market equilibrium on gig economy platforms is going to drive how the ICs decide to join. And the idea of having these two different levels of stochasticity comes from previous work of Ilan Lobel, my co-author on this work as well. Now, I don't want to go into the details of how this is actually formally set. The one driver that is sort of worth looking at is exactly the market equilibrium for the contractors. So I won't give you all the details of what this sequential game actually means because, well, one, I think Jinua wants to cut me off in 7-8 minutes. And two, it also goes into more details than would be interesting right now. But with the one thing that's interesting is this equilibrium condition, which basically says in a given scenario, meaning think of a scenario for this purpose as Friday evening, or let's say Friday morning, this morning, it is raining and the microeconomic conditions are whatever they are right now. And a driver decides whether or not to join the platform. Now, what this condition says is that this decision is going to be driven by their expected earnings on the platform. So they will have a fixed amount that they are willing to work for. That amount is pretty homogeneous across the population. And the earnings are driven by their utilization, meaning the probability that they actually serve demand multiplied by their per trip earnings. Now, this is a supply chain game, and we can serve such a supply chain game through what we call a subgame perfect equilibrium, SPE, which we'll always denote by S. And the way one solves such a supply chain game is through backward induction. What does it mean? It means that at each point in the game, think of this as happening chronologically, right? The long-term decisions happen first, like the arrows indicate the order in which things happen. At each point in the game, each player tries to do the best thing they could, given their expectation over what will happen in the future. And that expectation includes everybody else doing the best thing they could. So the platform is going to make a decision about how to prioritize its dispatch. But the supplier, when they set their supply level, are anticipating that decision by the platform. And when the platform sets the initial price, the set CP, which is how much the platform will get per demand served, at that point, it anticipates that the supplier will take that into account, as well as the future dispatch algorithm when setting their supply, their fleet size. So everybody thinks about the future and assumes that everybody else is going to be smart in the future. Now, what does misalignment mean? Our benchmark will be integration, meaning what if we only had one entity involved here? So rather than having the platform set the price and then the supplier set the fleet size and so forth, integration means that the supplier and the platform are the same entity, and the platform, we'll refer to it as the platform, just sets its fleet size itself, incurring the fixed cost itself, and not needing to think about how much to pay to another entity per usage, because it's the same entity. And what we want to understand is, well, what's going to be the relative profit between what we have in our subgame perfect equilibrium with two entities that both try to optimize over the future, and with integration. Now, what we find, and that's our first result, and potentially the most interesting here, is that in theory, this inefficiency, this profit ratio, can be arbitrarily large. So what do I mean by that? I mean, there exists an instance. And by instance, I mean, I need to set all of these parameters that occur in this sequential game. There exists an instance such that, sorry, I got to get the order of my operators right. If you give me a number m, I can construct an instance such that the profit loss multiplicative between the subgame perfect equilibrium and integration is more than a factor m away. So think of this as like, if m was equal to 2, that would mean the outcome in the subgame equilibrium would only be 50% of what it would be under integration, except for the factor here won't be 2, it could be 100, it could be anything. So the point being, you can really get an unbounded inefficiency from having this misalignment. So this is a pretty negative result. And in fact, this would even hold if the CP parameter, meaning the pay that the platform pays to the supplier per unit of demand served, was not set by the platform, by some social planner. For example, by the government that's trying to incentivize the adoption of autonomous vehicles. Now, at this point, we're in a pretty bad spot because it seems like things could be really bad. But what we find is that these bad results can be overcome through what we call contracting solutions. And what contracting solutions are effectively agreements made between the supplier and the platform that try to avoid such a bad outcome. So one very standard type of contract in the supply chain literature is what's called a revenue sharing contract, which basically means that for every trip that the platform serves, it will pay the AV supplier some share of its revenue that it obtains from the trip. Now, in the literature, we usually think of revenue sharing in contexts where there's really just one supply type. In this setting here, we have two supply types. And for revenue sharing to actually work, the platform would have to pay the AV supplier not only for rides served by the autonomous vehicles, but also for rides served by the contractors. So Lyft would have to say to Motional, we're not only paying you $3 per ride that the autonomous vehicles serve, but we'll also pay you $2 a ride for every ride that the contractors are serving. And the reason that that's needed is that the supplier needs to become indifferent to the dispatch prioritization. Now, this type of a contract, I would think would be unrealistic in this context, just given the fact that the supplier, just given the fact that the platform, I think, would have trouble justifying to its contractors why the AV supplier gets paid for every ride that the contractors are serving. Now, we can think of a different type of contract, which is what we call a usage contract. Now, usage contract, and I won't go into too much detail here, a usage contract you should think of as meaning that the platform promises to the supplier in each scenario for each amount of demand that realizes, meaning on a Friday morning when it's rainy and microeconomic conditions are of a certain type, if we're observing 100 requests of demand, I promise you I will serve at least 50 of them through autonomous vehicles, or I will serve at least 80 of them through autonomous vehicles. Now, it's important for this usage contract in this case that this minimum that is promised to the AV supplier to be served through the AVs has to be scenario and demand realization dependent. And in that case, we find that we can sort of align the supply chain, meaning whatever would be possible under integration and under revenue sharing would also be possible under such a usage contract. Now, those are two good results, but perhaps this one is still unrealistic because this notion of a scenario, you've probably realized over the last 20 minutes, is a bit iffy. It's not that easily defined. What does a particular scenario actually mean? And contracting on it might be even more difficult. Now, unfortunately, if we don't have perfect alignment, there's no way we can use usage contracts to get this type of perfect alignment. However, and here's the good news, we can always get approximate alignment. And the way we can get approximate alignment is through what we will call a full prioritization contract. So the platform would commit to always prioritize AVs fully, even if that's not in its own interest, in exchange for the supplier committing to supply a fixed number of AVs. So if you think back to the earlier example that we saw, this might lead to the contractor market collapsing, but we're okay with that. Under this contract, the platform will be okay living with that. The platform will always fully prioritize contractors. And what we can show is that one of the following will be true. Either under this full prioritization contract, the supply chain can achieve at least half of the profit that could be achieved under integration, or just not having any contract and being in the subgame perfect equilibrium achieves at least half of the profit. So this does not say, to be clear, that one should always use a full prioritization contract. What this says instead is that using either the full prioritization contract or just staying in the subgame perfect equilibrium will guarantee at least half the profit of integration, which is a lot better than arbitrarily large misalignment. Now, I'll skip the proof idea in the interest of time, the one thing that I'll say is that as we think back to about 8 months ago, when Kamesi and I were thinking about these problems, we were really not sure if there would be any contract that is not scenario-based that can give any sort of approximate alignment. We are really going back and forth on this. And the day that this idea came to us of using, basically, of having either the full prioritization contract or the subgame perfect equilibrium, once this idea came to us, the proof was very clean, and it basically took half a day to prove the result. So it was really this idea of having one of two that was the complicated one. The proof is very neat, and I will skip it in the interest of time. And I will just conclude with some numerical results instead. Now, numerical results in this setting, especially for us not being directly embedded in the AV manufacturing industry, are very hard. They are hard because we don't actually know what the right parameters are. And because of that, we sort of tried a wide variety of guesses. So the cost of contractors we set as being somewhere between 60 and 90% of the revenue of a ride. And we know that that's what platforms are doing today. The cost of AV operation, meaning the marginal cost, we set somewhere between 10 and 50% of the revenue of a ride. And if you're asking me why this parameter range, the honest answer is, I don't know, but it better be less than the cost of the contractors. And therefore, we went with these to cover a wide range of reasonable values. The fixed cost of the vehicle, of the autonomous vehicles, you should think of as this not being instantaneous, but of course, amortizing over time. And we're setting it as 2.5 to 40% of revenue. And that is independent of whether it's idle or not. So the cost of AV operation, that is marginal cost, whereas the fixed cost is independent of whether or not the autonomous vehicle is utilized. And then we assume just very simple demand settings where we have three scenarios: a low demand scenario with 10 to 20 units of demand uniformly at random, a high demand scenario with 30 to 40 units of demand uniformly at random, and a high variance scenario with 10 to 40. In reality, of course, the demand settings would be much more complicated. We would have much more scenarios, but this is meant to give some intuition here. And the intuition starts with the fact that misalignment can indeed be significant. It's not arbitrarily bad in these instances here. The instance that we construct to prove that theorem is a very pathological instance. What we find here is that the misalignment can be up to 26%. And across all of the instances that we tried that all came from these ranges here, we get a mean misalignment of 6.5%. And in the 90th percentile of misalignment, if you want, so the 10% highest misalignments are above 14%. So this is significant. This is not a small problem. Fortunately, full prioritization across the instances that we looked at mostly overcomes this. So I'm giving you here summary statistics, and you see the median under full prioritization. This is the middle column. The median misalignment under full prioritization is basically there is no misalignment. You get a ratio of 1.00. I don't remember if there's a rounding happening, so maybe there's a misalignment of less than 0.0%. Less than 0.049. You know what I mean, I hope. The point being, this is, if there's a misalignment, it's very insignificant under the full prioritization contract. Now, when do we find misalignment? In particular, in the subgame perfect equilibrium, when margins are thin. So if we scale all of the costs up, then misalignment gets worse. Not monotone, but it gets worse. One thing that's nice is that as we look at our instances that are all not as bad as the ones that we find in theory, as we look at our numerical instances, sometimes we will find what I would call the spirit of our two approximation result, meaning we know that the better of full prioritization and subgame perfect equilibrium is always pretty good. And what you see here is exactly that. The one scenario where full prioritization is not good is actually one where the subgame perfect equilibrium becomes pretty good. Now, let me conclude with a few takeaways. For platform operators, I think a big takeaway here is that saying we don't prioritize is still a prioritization strategy. There will always be some decision of how much demand is served through autonomous vehicles and how much through contractors. And that decision will have significant impact on market outcomes. Now, always prioritizing AVs is maybe the most natural decision given that they have a lower marginal cost, but it's also problematic because it may collapse the contractor market, and that may also not be a good outcome. And given that, the introduction of autonomous vehicles is likely to introduce supply chain contracting into platform operations. And speaking now very much with an operations management hat on and not with a transportation hat. In the past, I've maybe worn both. With an operations management hat, I find this very interesting because traditionally, as we think about platform operations, we really don't think about supply chain contracting because supply chain contracting is what occurs with high capital expenditure. And platform operations in the past didn't usually involve high capital expenditure because a driver deciding on a given day whether or not to drive is not a large expenditure. It's really a one day, one driver investment. Whereas a supplier deciding to buy 500 autonomous vehicles and put them on a platform in a given city, that is a much larger decision. So to conclude, this is a very speculative setting of how autonomous vehicles might be deployed in the future. For hybrid platforms, we find a surprising source of misalignment in the idea of AV utilization, underutilization. We show that theoretically, the worst case outcome can be really bad, but we also find that contracting solutions between the supplier and the platform can really have the opportunity here to yield significant improvements. And I'll stop here. Thank you very much.
Thanks, Dan. Thanks for, first of all, identify and share with us this potential a huge problem here, right? There could potentially be a growth inefficient that happening on this, even though you position as a future scenario, but as many audience point out, that there are a lot of pilots going on today, and this may be a very likely, even probable challenge that you just identified. So thank you for raising this. So I'll start from the question from, given the particular setting you choose, and then move to some additional setting that I'd like you to get your opinion on. So within the setting first, in the numeric example, you're showing that with the full prioritization, the efficiency can be very high, right? I mean, the misalignment seems small, but in the proof side, you put a lower bound of 50%, right? Even the numerically is very high. So why? Tell us the gap between the theoretical proof versus the numeric example.
I think there are two sources here, one from each direction. One direction is we really wanted to have plausible instances. So when I gave you the range of values, yeah. They were back of the envelope parameter guesses. I'm not trying to argue here that those are the actual values, but they are, if you want, they really are guesses, and we didn't want to go into like absurd values. So in order to prove the theorem, we sort of need to allow arbitrary parameter ranges, and that's where we get sort of the bad settings. So yeah, so that's really the one side. The other side is for the true approximation, that's an upper bound. So maybe the true value would be a 3/2 approximation. And you asking this question gives me more ammunition to tell Kamesi that this is something we should explore.
Nice. Given the time, we'll give you a bunch of questions together. So we still give a John so that audience question can be answered. So a few things, right? One is about this usage contract. So it can reach a perfect solution if they can negotiate under each scenario. But as you say, scenarios, there's an infinite combination there. But is it possible to have at least a majority of the scenario being predefined, therefore negotiated out, and therefore whenever happens, you trigger this set of contract on that. So that's one. The second one is going beyond your setting of this problem to say there are interesting business models like for individual AV owners to lease their vehicle into the market whenever they don't use it, right? So this will broaden the AV supply side to a multiplayer, many player situation, right? How would that potentially change the discussion here? And the third one is here I assume that you are talking about one single platform. But in practice, you often have Uber, Lyft, Via, you may have multiple platforms play with each other on this, right? How would that complicate the problem?
All right, I hope I'll remember them as I answer them. Let me start with the second one. So the second one was the question about individuals basically leasing their autonomous vehicles out to the platform. That's very possible, and we don't capture that. And it would have profound implications for our results. The two caveats to that are, one, if you look at the sort of quotes that I provided early on, so like CEO of Waymo says, we do not see AVs as being sold widely to the public. We see AVs as being put on platforms. That sort of makes it a little bit unlikely. If you think a bit further, there's a question of who's going, if they are being sold to the public, there's a question of who's going to own them. So if this is something that, like, let's say an autonomous vehicle, and I'm throwing out a number, please do not take this as any educated guess. Let's say we're talking about a $200,000 expense. I would personally have a bit of a hard time imagining that individuals who spend $200,000 to buy an autonomous vehicle would then necessarily be willing to lease it out to the platform every day, which basically means you need to empty the trunk and everything else every day. There's an inconvenience associated to that. And I'm not sure, and I honestly have to say, it's not in our model. I'm not sure if there's actually large overlap in population between people who would be willing to lease it out and people who would actually be able to afford it. So that's my response to question 2. That being said, if that is the world that we end up living in, it's completely correct. That would very much change the insights that we're finding. Now, the third question was about what if we have multiple platforms? Then things get a lot more complicated, because then suddenly there's a question of how are the AVs going to be sent to each platform? What do I mean by that? If you look at the pilots that are currently running, say in Las Vegas, you have dedicated vehicles on the Lyft platform and dedicated vehicles on the Uber platform. And in that case, if vehicles are dedicated, the results don't necessarily change that much. If autonomous vehicles sort of on any given day can, at any given moment really, get a request from either platform, then things get more complicated in many ways. And I don't think the literature actually has all that much to say for sort of the true competitive dynamic setting that we would be in. And neither do our results to some extent. And the last question, of course, I forgot.
Is the scenario, can we pre-construct majority of the scenarios and the trigger when it happens?
So the difficulty is, so first of all, we don't know, and we don't have good results in that regard. Here's what we do know. So if you imagine, for example, something that is observable that you could contract on, which is the demand that arises. So ignore scenario and just look at the second level of stochasticity, which is how much demand actually was there. How many people requested a ride and how much of that demand got served, either by autonomous vehicles or by contractors. Those are all things that one can know. And that information would not be enough to align the supply chain. So that we do know. So the question really boils down to, can you somehow discretize the space of scenario outcomes in such a way that you can almost get what you would get under perfect integration? And I think it might be possible, but we haven't thought that much about it.
Good. Thanks,
That's
Dan.
a great question.
Yeah. John, for the audience question.
Super. Well, thanks so much, Dan. As you saw, we had a super active chat, and we will capture this and send it over to you because there's a lot of actual really great content in the chat. One question just to start is from Sarah Golde, who's the Chief Data Scientist at VIA. And Sarah, please feel free to jump in, but some of your questions were already addressed, but I thought he also had a very interesting comment, which is, it's very, very hard to get drivers to work only during peak hours. And I just wonder if you have any sort of thoughts or reflections on that human dimension.
So I think that can really have either implications. So we're making this assumption that's driven by this quite famous paper by Hall et al. That suggests that basically drivers will join as long as their average earnings are high enough. And we are making the assumption that that is scenario based, meaning drivers would be willing to join, for example, only at 3 particularly busy times rather than at all times. I think that there's a valid question as to whether or not that's realistic. I think for some drivers, it surely would be realistic. For others who really want a full-time gig, it definitely wouldn't. One piece to keep in mind in this context is also that this very much depends on how the gig economy overall evolves. Because if people can spend their Friday evening driving for Lyft, but can find gig employment at various other times during the week, then it sort of seems more likely that this could work, and I emphasize could. If people are unlikely sort of to find gig employment for the rest of the week, then it's really a different set of population that would have time on Friday evening. So this is a very valid point, and I think it would be interesting to explore what other constraints on the gig or the contractor participation would still sort of yield the same results that we're finding. Thanks, that's a fantastic question.
Super. So there's also a whole family of questions around the business model, and in particularly the distinction between these kind of two categories of companies where we have, sort of like Uber and Lyft on the one hand, and then we have, of course, Cruise and Waymo on the other hand. And I wonder, Evangelos Simoudis, are you on with us? Maybe you could ask the question that you posed.
I'm here, and there's so much activity. I forget what the question was, to be honest with you. So if you pose it for me, that'd be great.
Sure, you bet. I mean, it was basically diving into this. What are the economic incentives, or what's the advantage to kind of the cruise approach versus the motional working with Lyft or Uber approach? Do you have any sort of thoughts on the business model?
Yeah, that's a fantastic question, and this goes deep into models that are much older than the question of autonomous vehicles, which really go to the theory of the firm and like what is really the sort of how much integration vertically do you really want? My take would be that if I think about a company like Cruise, I do not think that they want to have the headache of dealing with contractors and all of the various problems that arise in having contractors on the firm, legally, in terms of political backlash, all of these things that come into that. At the same time, one sort of side corollary of our results is that you do operationally want to have two different types of supply if you can. Because basically stocking up AV fleet size to serve peak demand on St. Patrick's Day is not going to be feasible because those vehicles will be idle most of the year. So there is a sense that you do want to have the hybrid fleet. And I think once you have the hybrid fleet, a lot of AV companies may not be willing to actually deal with that side. So in that regard, there is a natural reason, or there is a set of natural reasons why you may want to sort of have different entities. That being said, if you had integration, if a company like Cruise or Waymo decided to acquire a company like Lyft, then these results would no longer hold. Whether or not that's in the future, I guess that's why I began the talk by being very clear on this is a speculative setting, and not all of the things that we describe we can really vouch for actually that being the path forward.
I think we can squeeze in just one last question here, which is from RJ. Has there been any research into the rideshare market in Phoenix before and after Waymo began AV operations? Understanding of this changed how Lyft and Uber operated there could be interesting. Are you aware of anything there, Dan?
Actually, I'm not. And I agree, though, that it would be interesting to look at it. I think one problem that we have in sort of a lot of these settings in the last 3 years is that we had such a big shock from the pandemic that it's very difficult to sort of disentangle between Waymo really like driving up operations and how much that would have changed versus how much shock just came from the pandemic, which of course also had hugely heterogeneous effects sort of in different places. But I want to say that would for sure be a really interesting topic to study.
Great. Yeah, sorry to cut in here. There's so many other good questions there. But given the time, I want to thank Dan for the presentation and the conversation, and also have two announcements to the whole audience here. One, MIT will continue to have our TRB reception on January 10th, Tuesday, 5:30 to 7:30 in the Marriott Hotel as part of the TRB conference. All the audience here are cordially welcome to join us. We've been doing this online for the last year, then we recovered this year to do in person. Hope to see you guys, many of you guys there. Secondly, the MIT MST and PhD program admission deadline is January 4th. Please help distribute this information and encourage the talent student to apply. Particularly the minority student, the people from developing country, if you have contact, please do encourage everybody to apply on this, right? I'll say today is the last session of the 2022. We have a very good run for the 12 sessions. And Dan, thank you for giving us a brilliant conclusion on this. For that, I would say I'll thank my partner, John Momanzadi and Bhuvan Ataluri for hosting this session. Also thank all the audience for participating. I do have a request. Please share with us what have you learned throughout the 12 sessions, and tell us what do you want to see in the future. So thank you, Dan, again, and thank everybody. Have a great holiday. See you in 2023. Thanks, everybody. Thanks, Dan.